Okay, chapter 1, section 4A. Solving by factoring or square roots. Okay, your quiz on Friday is going to be 1.2A, which was linear, 1.2B, which was yesterday, rationals, and then 1.4A, which we're doing today. Tomorrow we're going to do the first part of completing the square. We'll finish that up the following Monday, but you guys will not, that won't be included on the quiz. So when we are talking by solving by factoring, guys, this is when you have like an x squared and an x in one equation. You're going to solve by factoring, meaning you want to move everything to one side, factor your equation, and then set each parenthesis equal to 0. Okay, so we're going to initially get everything to one side, which we do here. Do you see how in question 1, there's just an x squared and a number? So then you can just have letters on one side, numbers on the other. When you have to move everything to one side and then factor is when you have an x squared and an x value, because then you can't just erase those or cross them out or anything like that. So in question number 1, do you guys see how you have x squared plus 1? So, minus 1. So we're going to add 1 to both sides. You get x squared equals 1. How do I solve this? Take the what? Take the square root. Guys, when you physically put the square root on top of a number, what goes in front of your answer? Plus or minus. So your answer here is plus or minus 1. If you only give me one of the answers, it's only half. Positive 1 and negative 1 are complete answers there. Questions on that, just so we understand. Absolutely. You could have done difference of perfect squares, x plus 1, x minus 1. Yep. That would have been fine. That would have been factoring it. Yep, you could have done here. Plus 1, minus 1. Set each parenthesis equal to 0. You get positive negative 1. Perfect. All right, in this case, you have to move everything to one side, guys. You cannot just divide both sides by x. It does not work like that. We need to subtract x from both sides. So here we're left with x squared minus x equals 0. You guys with me? I understand I went down to 3. Just follow me. It's no big deal. Now, how do I solve this? How do I factor it? What's the first thing we always look for when you're factoring? GCF. What do they have in common? X squared and x. And x. So if I take out the x, I'm left with x squared minus what? No, I'm not. I'm left with what? X minus 1. Good. Then what do I do with each piece? You set it equal to 0. So x equals 0 and x minus 1 equals 0. So your two answers here would be x equals 0 and x equals what? Perfect. You set each, after you factor it, you set each piece equal to 0. So you set the x equal to 0, and then you set the parenthesis x minus 1 equal to 0. Move everything to one side and factor it, and then once you factor each piece that you factored out, you set equal to 0. So if we look at number 2, right, is everything on one side? I have an x squared and I have an x to the first, so I have everything on one side, correct? Okay, so we're going to factor. When we factor, we look for the GCF. What do they have in common? An x. So if you divide out that x, it doesn't go anywhere, guys. Remember, you can't just leave it alone. You pull it out in front, and you're left with 3x plus what? Plus 1. X divided by x is 1. Now, what do we do with each piece? You set it equal to 0. So I have x equals 0, and I have 3x plus 1 equals 0. So when you solve, you have x equals 0. And then when I solve over here, you guys are going to subtract 1. So 3x equals negative 1. Divide by 3, and x equals what? Negative 1/3. Good. How many answers have we gotten for each of these so far? 2. You guys don't need to know this right now, but what's your highest exponent in here? 2. Whatever the highest exponent is of your polynomial, that's how many answers you should get. Whether they're all real, imaginary, combination of both, that's how many answers you should get. It's okay. No worries. All right, look at the next one. Is everything on one side? Yeah. Yes. I have x squared plus 2x minus 8. Can we factor this trinomial? We sure can. What are the factors of negative 8? That multiply to give me negative 8, but add to give me 2. X plus 4 and x minus 2. All right, now that we factored, what do we do with each of those parentheses? We set them equal to 0. Good. And guys, like I said last week and this week, what can you do? What is the beauty of solving equations? What can you do with your answer? You can plug it back in. When you guys give me your quiz, you should know, oh, I got them all right. Oh, I know I got all these right, but I'm iffy on this one because when I plugged it back in, it didn't work, something like that. So you should be able to go back and check all of your answers. Is it harder to check the fractional ones? Yes. Don't just skip, actually try to do it. All right, number 5. Same thing, right? We have a quadratic. I have an x squared and an x. Everything is on the left-hand side, so we're good to go. So let's factor this. Factors of 2 times negative 15 is what? Negative 30. So what are the factors of negative 30? They're going to multiply to give me negative 30, but add to give me a negative 1. X minus 6, x plus 5. Now, I might do this differently than you guys when your A term is not 1. Do whatever works for you. But the way that I do it, what do I have to do with my A term? I have to divide both of my factors by the A term. Does 6 divide by 2 nice and pretty? Yep, becomes x minus 3. Does 5 divide by 2 nice and pretty? No, so this becomes my coefficient. 2x plus 5 equals 0. Now, what do I do with each of those parentheses? You solve it. So I have x minus 3 equals 0, and 2x plus 5 equals 0. So over here I have x equals what number? 3. And over here I have x equals what? 5. 2x plus 5. I move 5 over, it becomes what? Negative. And then I divide by 2, so it's negative 5 over 2. I'll go to the right to 6, because I know it bothers you guys when I go out of order. How is 6 a little bit different? It's not all to the same side. Good. We have an equals 3. So we need to have everything on one side and your equation set equal to 0 before we solve. So what is the first thing I need to do? Perfect. I need to subtract 3 from both sides. So now I have 2x squared plus 9x plus 4 equals 0. Now, is this a trinomial we can factor? Absolutely. So a times c, 2 times 4 is positive 8. What are my factors of positive 8? That'll multiply to give me positive 8, but add to give me a 9. Perfect. X plus 1 and x plus 8. Now, since my a term is not 1, it's 2. I'm going to divide both sides by what? 2, right? So 1 divided by 2 is not pretty, so we'll say 2x plus 1. And 2 becomes the coefficient here. And then 8 divided by 2 is pretty. What's 8 divided by 2? 4, good. And then what do I do with each piece? I set it equal to? Good. So 2x plus 1 equals 0, and x plus 4 equals 0. So when I move 1 over, hang on one second. When I move 1 over, it becomes what? When I move positive 1 to the other side, it becomes negative, and I divide by 2. So here I have x equals negative 1/2, and here I have x equals what? Negative 4. Can you guys see that negative where I put it? Angel, question, honey.
I noticed that like when you have something like that, the x's equal what you have there with the it looks.
It what?
Is there any kind of pattern there going on when you divide the when you have the x plus 1 and the x plus 8 and you divide them by 2? So the coefficient of the x, right?
Is there a pattern, you ask?
Yeah, because when you have that, you have the 8 over 2 and x and 1 over 2. You final answer came out and then 1 over 2 4. So is there a pattern there?
You mean from here? You could just solve it. I mean, if you in your mind, like think about it. If you had x plus 8 over 2, if you moved 8 over 2 to the other side, it would become negative, right? Yeah. And then negative 8 divided by 2 is just negative 4. All right, look at number 7. How's 7 a tad different? Not everything on the same side. So when we move, I have 6x squared minus 3x equals what? 0. So first thing we look for is a GCF. What is the GCF between 6x squared and 3x? So I'm going to divide out the 3x. If that helps you by putting it underneath, go ahead and do that. But remember, it goes out in front. It did not leave us. 6x squared divided by 3x is 2x. Good. What's negative 3x divided by a positive 3x? Negative 1. Good. Now what do we do with each piece, guys? Set it equal to 0. So 3x equals 0 and 2x minus 1 equals 0. So when I divide both sides here by 3, my x equals 0. And then I'm going to add 1 and divide by 2. So x equals what? 1/2. Good. Ask away, kiddo. Okay. All right. How do we feel about the next one? Kind of the same thing again, right? Very repetitive. If I move this 2x over here, this becomes 8x squared minus 2x equals 0. Not a good color choice. What do we have in common between 8x squared and negative 2x? Good. I'm going to divide out that 2x. Where does the 2x go? Out into thin air? No, we're going to put it out in front, and then I'm left with what? Perfect. 4x minus 1 equals 0. What do I do with each piece? Set it equal to? Perfect. Good job, guys. So on the left, I'm going to divide both sides by 2. I got x equals 0. And on the right-hand side, if I move negative 1 to the other side, it becomes positive. And then I divide by 4. So God bless you, I get x equals 1/4. And again, guys, I keep saying the same thing, I know, but what can I do every single time to say, ooh, look at me, I'm so smart. God bless you. What can I do with my answers? Plug them back in. Good. All right. Number 9, same kind of problem. Same problem. What do I need to do, though, first? Everything to one side. God bless you. Some of you are going to want to say, I want to move the x squared to the other side. If you do that, fine. But a lot of you are making major mistakes with your signs when you factor with a negative leading. So I would I would add 6x, and I'd add 9 to both sides. So you have x squared plus 6x plus 9 equals 0. Does anybody notice anything about this? It's a perfect square what? Trinomial. All right. If you did not notice that, no big deal. You could say, what are the factors of 9 that multiply to give me 9 and add to give me 6? What would that be? So x plus 3 and x plus 3. So what's your answer here? Yep, you have x plus 3 equals 0. So x equals what? Negative 3. How many times do you have x equals negative 3? Twice. All right, you don't have to write it twice. If you show me your work like this, you understand that. That's something called multiplicity. We'll talk about that much later on. But multiplicity just means you have the same answer more than one time. Fun fact. All right, number 10, assess the situation. Do you have everything on one side of your equation and it's set equal to 0? Yes. So I'm going to say, okay, let's go ahead and factor this. Now, is there a GCF? No. Does anyone notice anything about this problem? Is this a perfect square trinomial? Well, let's think. 2x and 2x, right? 3 and 3. And then how do you figure out if this is a perfect square trinomial? A times b times 2? What's 2x times 3? 6x times 2. Does it give me 12? Yes, so this is a perfect square trinomial. Say you guys got here and guess what? You didn't recognize that. Can you still solve this by factoring? Yes. Multiply a times c. 4 times 9 is 36, right? What are the factors of 36, excuse me, that multiply to give me 36, but add to give me 12? 6 and 6? Okay, so x plus 6, x plus 6. Since my a term is not 1, it happens to be 4, I have to divide both of these by that term, correct? Does 6 divide by 4 nice and pretty? No, but it does simplify, doesn't it? 2 over 3? Just kidding. 3 over 2. I'm thinking ahead to where I'm about to go. And then this becomes plus 3 over 2. Agreed? All right, so if I was going to bring this out here, we get 2x plus 3. And we get 2x plus 3 equals 0, which is what we got at the beginning when we said, oh, it's a perfect square trinomial. So what do you do with each piece? You set it equal to 0. So x equals what? If I move 3 over, it becomes what? Negative. Good. And then I divide by 2. So what Angel just said a second ago, Frank said this before when we first started doing this. When you are here and you're solving, right? If I had x plus 3 over 2 equals 0, and I wanted to solve this, don't you agree you would just minus 3 over 2 from both sides? So you get x equals negative 3 over 2, which is what we got right here. I'm just fully factoring it first so you guys can see the two factored binomials and then solving. All right, let's look at this one. Is this tricky? No, it's not. Is everything moved to the left-hand side set equal to 0? Yes. Do I have any GCF that I need to get rid of? No. Can I just factor this normally? Yes. What times what gives me a negative 8 when I multiply, but a negative 2 when I add? Perfect. X minus 4, x plus 2. What are my two x values? Positive 4, negative 2. Good job.
Wait, why wouldn't it be negative 4 and positive 2?
That was negative 4 and positive 2 were in our parentheses, but when you set them equal to 0, like x minus 4 equals 0, you're going to add 4 to both sides. That's where I got x equals 4. All right, here we go. Some of you are like, oh, I love to factor when I'm leading with a negative, and then I'm going to get all my signs messed up. Guys, don't do that. Move everything to one side, and I want my x squared, God bless you if you just sneeze, to be a positive number. So I'm going to first subtract 3 from both sides. You guys agree? So negative x squared plus 4x minus 3 equals what? 0. Okay. Now what? Let's go ahead and get rid of that negative 1. Let's divide out a negative 1. I'm going to show you guys something, right? I'm going to divide out a negative 1. So I'm going to put that negative 1 out in front because it didn't go anywhere, right? I'm just relocating it. So this gives me x squared minus 4x plus 3 equals 0. You don't have to keep that negative 1 out in front, but I'm doing this to show something because you guys will see this later on. So I still have my negative 1 out in front. Can I factor this now? Are there factors of positive 3? That'll multiply to give me a positive 3, but add to give me a negative 4. Negative 3 and negative 1? Okay. Now, the first few examples, remember we factored out the GCF and it was like 2x, 3x, and then we set each piece equal to 0. So we got x equals 0. Same concept applies here, guys, but I want you to see something. If I set negative 1 equal to 0, is that ever a solution? No. So if you ever factor out a GCF and it's just a number, it doesn't have an x attached to it, it will not be accounted into your solution. Think about this. I told you at the very beginning, the highest exponent tells you how many answers you have, yeah? What's the highest exponent here? 2. So how many answers should we come out with? 2. So x equals negative 1 or something like that. That is not a solution. If you take out the GCF and it's just a number, it will not be included in your solution set because it's not. So now I have x minus 3 equals 0 and x minus 1 equals 0. So what are my two x values? 3 and 1. Perfect. Very good. All right, come to 13. We see a fraction. So immediately we should freak out and say it's the hardest problem ever. We can't do it, right? Yeah. Okay. And we're like, okay, what times what is going to give me 1/8? You could do that if you want, but what's something that would probably be the best thing to do? How could we get rid of that fraction? Multiply everything by what? 8. Let's get rid of the fraction. Do you absolutely have to? No. If you want to factor the fraction, feel free. I don't want to. So I'm going to multiply everything by 8. So if I multiply here, what do I get?
1x squared.
Because it's 8x squared over 8, right? This would be 8x squared over 8. Do you guys? I'll write it all out. Then I have minus 8x. Then I have minus 16 times 8. How could I figure that out? Without a calculator, guys, what could you do?
10 times 8.
You could write. Look, you can go just like this. Watch. 16 times 8. It is 128. There you go.
Also do 10 times 8 and then 6 times 8.
Perfect. You can do it that way. Now, can I simplify anything before I go ahead and try and factor this? What's 8 divided by 8, guys? 1. The whole reason that we did that was to get rid of that fraction. So we have x squared minus 8x minus 128 equals 0. All right, are we going to have to think of tad? Yes. But I have x in the front of each parenthesis. What times what gives me a negative 128 when I add? Sorry, multiply. And a negative 8 when I add. Negative 16 and positive 8. All right, did Paul Davies just know that off the top of his head? Maybe. Or, a lot of you did this on your quiz or your test, which was great. 1, 128. 2, 64, right? You write out your factors. It's a good idea, guys. You're going to have to do that, right? Math is going to get a little math here. It's going to get harder, so we got to be able to use a little mental math. So what are my two answers here? X equals what? 16 and negative 8. And again, what can I do with my answers to certify that I'm correct? You can plug them back in. Good. But as soon as you guys see fractions, go ahead and multiply. Multiply through the LCD and then get rid of them. Makes life a lot easier. All right, now we're going to solve equations by square rooting. Remember what we said at the beginning. If you physically put the square root on a number, if it says x squared equals and you put the square root on, what has to go in front of your answer? Plus or minus. You have to account for both answers. So if I look at something like this, I have x squared on one side and I have 15 on the other. I'm going to show you two different ways you could do this. We could just take the square root and you get x equals what? Plus or minus the square root of 15. Does the square root of 15 break down? No. If the root does break down, you need to break it down. Another way you could look at this is you could have factored it. X squared minus 15 equals 0. And then you would have to break it down into root 15 and root 15. I don't know if we're there yet, so I wouldn't worry about it, but that's how that works out. Now on WebAssign, they're going to ask you for a value, and then they're going to ask for the approximate value. So you're going to have to use the calculator on WebAssign for the approximate value. That will not be on the quiz, because you're not going to have a calculator. But on WebAssign, it's going to say, what is the exact? Exact means under the root. And then on WebAssign, it's also going to ask for the approximate. So you'd have to put it in your calculator and then round. Yes, sir?
Round to the
It'll tell you. Probably 2. All right, what about here? I have x squared on one side and a number on the other. How do I solve this? I take the... Okay. So I get x equals what goes in front of my answer, plus or minus, and then I have 48. What do I now have to check to see if this breaks down? Okay, now some of you are still having issues breaking these down. We've got to get a handle on this. Couple ways you can do it. Some of you see right away the first perfect square, the biggest and the smallest, biggest perfect and the smallest non-perfect. Some of you don't. If you're still having issues with that, guys, write 48 over here and say, okay, what goes into 48? 2 goes into 48 how many times? 24. 2 goes into 24 how many times? 12. 2 goes into 12 how many times? 6. 2 goes into 6 how many times? 3. So when you break this down, anything that's a pair, you can bring out in front. So I have one pair of 2s, correct? I have another pair of 2s. And then what stays underneath? The square root of 3. So this is x equals plus or minus, what's 2 times 2? 4, square root of 3. Some of you said, oh, 48, that's 16 times 3, right? What's the square root of 16? 4, is that the same thing we got? Some of you are still writing your factor trees and you have factors all over the place and you don't know how to group them. That's why I don't like the factor trees, because you got a branch over here, you got a branch over there. I think the best thing to do is the upside down division, and then anything that is a pair you can pull out in front. Just my suggestion. We can go over more of those later if you want to. All right, 16. 16 is a little bit different. 16 is a little different. I don't know if there's any other examples that I wanted to... All right, when you have a situation like this, the first thing you want to do you see how you have 4x plus 1 quantity squared? Yes? What does that mean?
foil.
It means, if you needed to, it would mean to FOIL. But we're trying to break down, we're trying to solve. So we're going to undo. if there was anything added or subtracted, don't write this down, but just say this was like 4x plus 1 squared plus 12 equals 20. You want to isolate your parenthesis first. So what would you do? You minus 12 from both sides. Okay. Not the case here. I'm just saying, when you're solving these, when you have a parenthesis that's squared or cubed or anything, in order to undo, what's the opposite of squaring something? Taking the square root. You cannot do that until this is completely by itself, which it is now. So what am I going to do? I'm going to take the square root of both sides. So I'm left here with 4x plus 1 equals what? Plus or minus, perfect, the square root of 20. Now, does 20 break down? Yes. Don't worry about it right this second. We'll do it at the end. Because we're trying to get x all by itself, correct? So if I'm going to isolate x, what do I do first? We're going to subtract 1. Okay, watch how I do this, guys. 4x equals, I have, you can write it either way. I'm going to write negative 1 plus minus root 20. What's another way I could write it? Plus minus root 20 what? Minus 1. The problem with that is sometimes that negative 1 will sneak under the radical, and then you guys are like, oh, 20 minus 1, that's 19. No, no, no. The square root of 20 is its own entity. We're leaving it alone. Now, what's the last thing I need to do here? Divide by 4. Perfect. So I have x equals negative 1 plus or minus the square root of 20 over 4. Now, lastly, we have to break down. What can I break down 20 into?
5 and 4.
Okay, the square root of 20 is 4 times 5, correct? Yes? Okay, so when I take out the square root here, it becomes what? 2 square root of 5. So I have negative 1 plus 2 square root of 5 over 4. I am fine if you leave it here, just like that. How could we simplify? You could write it as negative 1/4 plus or minus what? Root 5 over 2. How did I do that? Well, since you have a plus or minus in the top, that's 2 different terms over the same denominator. I am fine if you leave it here. You do not have to simplify anymore, unless both terms simplify. If both of them do, great. But if not, just leave it. You guys okay? All right, scoot along. X squared minus 43. Is this the difference of perfect squares? No, we don't know how to break this down. So let's just go ahead and add 43 to both sides. You have x squared equals 43. Now what? Take the square root. Perfect. So you get x equals plus or minus. Is there a perfect square and a non-perfect square in 43? No, so just leave it. Now on WebAssign, it might say enter the smaller value first and then the larger value. Guys, what is the smaller value? Negative root 43 or positive root 43? Okay, just make sure we understand that. Good, good, good. All right, great. All right, I have x squared on one side, number on another, but my x squared is not by itself, so what should I do? Say again? Okay, divide by 9, perfect. Does 36 divide by 9 nice and pretty? Oh, well, that's super, right? 36 divided by 9 is 4. And then how do I solve this? Take the square root, so I get x equals what goes in front of my answer, plus or minus, what's the square root of 4? Perfect. You guys are doing great. This is pretty. I have x squared on one side and a number on the other. I don't have an x to the first power. We can't factor this anything else. What can I do here? I need to isolate my x squared. Divide both sides by 25. Perfect. Okay, guys, in your head real quick, what's 37 divided by 25? It's not pretty, right? That's okay. How do I get x all by itself? Take the square root. Okay, so this becomes x equals plus or minus. If I have a square root underneath the radical, I could rewrite it as the square root of 37. You can break it up as square root of 25. Why is that a good idea for me to do here? You don't want a square root in the denominator. Good. And what do you notice about your denominator? It's a perfect square. So this would become x equals plus minus the square root of 37 over what? Perfect. Good job. Very good, guys. All right, in a case like 20, remember, before we take the square root, we have to make sure that the parenthesis that's squared is totally isolated. Is it? Yes? Okay, great. So how do we solve this? We're going to do what to both sides? Take the square root. So I have x plus 5 equals what? Equals what? I changed it to plus, sorry. X minus 5 equals what? Plus or minus 5. Guys, don't leave it like this. All right, any other time when we have a lovely radical, and you'll see this in a second. If I'm going to simplify this, what would I do to both sides? I'd add 5, right? So add 5. So this is actually two different problems. This is plus 5 plus 5, and over here this would be negative 5 plus 5, correct? Go ahead and simplify here. If you had radical 37, then no, you wouldn't simplify because we don't know what it is. But guys, if you have a whole number or something that simplifies, go ahead and do that. So what are my two answers here? X equals 10 or x equals 0. Good. If you ever have something that can be simplified, you need to go ahead and do so. Don't leave it as plus or minus 5 plus 5. That's silly. All right, same thing here. We're doing the same thing. Is your parenthesis that is squared isolated? Nothing in front of it, right? All right, so go ahead. What are we going to do? We're going to take the square root. So I have x plus 9 equals. What goes in front of my square root? Plus or minus 24. Now, you can simplify here if you want to. I'm going to wait till the end because I want to get that 9 to the other side. I want my x isolated. So what do I do to both sides first? Subtract 9. Guys, can I subtract these two things and get a one singular value? Yes or no? Can you combine the square root of 24 and the whole number 9? No. So this just becomes x equals, I'm going to put the 9 first, so negative 9 plus or minus the square root of 24. We now have to break down. You have to figure out the perfect square, non-perfect square in 24. What is it? 4 and 6. What is the square root of 4? 2. So this becomes x equals negative 9 plus or minus 2 root 6. Can you simplify any more? No. This is negative 9 minus 2 root 6 and negative 9 plus 2 root 6. That's a totally fine answer. Going 100 miles an hour, I know. We only have 2 more, then we're done. You guys are doing great. 2 more, let's go. Again, we're going to look. We're saying, okay, we need to undo. Got to get this parenthesis not squared anymore. Is your parenthesis isolated? Is there anything being added or subtracted, multiplied, or divided to it? No. So we're going to do what? Take the square root. So let's do that. If I take the square root here, and I take the square root here. So I have 4x plus 7 equals. What goes in front of root 44? Plus or minus. Good. Just how we keep doing the same thing over and over. I'm going to simplify root 44 at the ends, but I want to isolate x. I have 2 things I need to do in order to get x by itself. What is the first thing? We're going to subtract 7. Perfect. So you have 4x equals, I'm going to put 7 first, so negative 7 plus minus root 44. I think that's a good habit to get into so your numbers don't sneak underneath your radical. And then what's my next step? Divide by 4. Okay, so divide by 4. If you get this far and you leave it, you're going to get some points off because you did not fully simplify. But you're on the right track. How can I simplify the square root of 44? It's 4 times 11, right? So when I break this down, the 2 comes out in front. So I have x equals negative 7 plus minus 2 root 11 over 4. Am I okay with that? Yes. If your first term was an 8, would I be okay with that? If it was -8 plus minus 2. No, because you could simplify. If you wanted to simplify a little bit, you're more than welcome to. This would be -7/4, because that does not simplify. And then you have plus minus what? √11/2. Some of you want to go that extra step. You do not have to. I'm totally fine with you leaving it just like that. Questions? All right, let's look at the last one. Whoa. Okay, don't freak out. Let's just look at it for a second. You want to get your parentheses isolated. Is there anything being added or subtracted on either side to either of them? No. If you have a parenthesis squared on one side and a parenthesis squared on the other side, well, what do you do to get rid of the squares? You take the square root. Good. What happens when you square a square root? It cancels. That's it. So you have x plus 5 equals what? X plus 4. Okay. Simple enough. Now what? Move your x's to one side? Agreed. So I'm going to subtract x. Now what? Move your numbers to the other side? Agreed. So I get x cancels. This is 0 equals x cancels -1. Huh? It's not true. So what's my answer here? No solution. There is nothing in the world that you could plug in for x that would make this equation true. So no solution. How did you know it was no solution? Because you came out right here, x equals -1, with an untrue math statement. What about if it came out as 0 equals 0? What would your answer be? All reals. Good. Understand the difference between those two things. Questions? All right, you guys have a web assign. We only have about 8 more minutes, but you're welcome to start it if you want to. Tomorrow, any questions you have on homeworks and stuff we'll go over. I'm going to do the first part of completing the square, which will not be on your quiz. And then Wednesday in class, we're going to do some sort of a review. Class kick, something like that, to get you ready. Sorry, okay. My days are all messed up. Okay, so tomorrow we're going to do the beginning of completing the square. I'll answer any homework questions from the last 3 sections. Thursday, my apologies, we're going to review, and then Friday we'll take our quiz. Sound good?